All right, Mr. D here, and it is time to start with Lesson 1, which is our field trip navigation assignment. So, let's take a look. All right, field trip navigation looks like this. It's to help us review algorithms. Algorithms are just a series of events that help us complete an action, or really simply, a list of steps. And if you remember, all of computer science is algorithms. That's all it is figuring out what is the algorithm to do what I want the computer to do. So, to help us get used to thinking about algorithms again, we have this field trip navigation assignment. So, first part, you're going to have a street map. This street map looks like this. Street map. And it says to figure out how to get from the school to the museum. Write out a list of steps. That's what this says. So look at the street map with your partner and determine a route for the school bus to get from the school to the museum, and then write out a list of steps using only these commands. Begin, move forward, turn left, turn right, move backward, and end. So really that's just it. Step 1, step 2, step 3, step 4, step 5. How do you get from school to the museum? Then it says to test it. Test your algorithm by following those steps exactly. Okay, well that makes sense. I'm going to zoom into the document here a little bit so you can see better what it looks like. Okay, but now we're going to write our algorithm as a flowchart. Flowcharts are just a way to make our algorithm visual. And at the beginning, it might seem like this is kind of a pointless step, but it becomes important later on because as our flowcharts get more complicated, or as our algorithms get more complicated, it helps to make them more visual so we can understand them. So at the beginning, you got this linear flowchart, which is just start, step 1, step 2, step 3, step 4, however many steps you have, and that's the end. Linear flowchart just means it's a straight line from beginning to end. If I had a real linear flowchart, it might look something like this. Start, put on shirt, put on pants, put on socks, put on shoes, and end. That's a algorithm for getting dressed. Make sure when you're doing it, these are the only symbols we use. Right now, however, we don't have any yes or no decisions. You just have a list of steps from getting from the school to the museum. So here's the thing. Algorithms sometimes have to account for yes or no questions and making decisions. So that's what this step 5 here is just what are some yes or no questions? Is it raining? Yes or no? Is it cold out? Yes or no? I want you to just think of a couple of yes or no questions. And then let's look at this. This is an algorithm that includes a yes or no question. When we have an algorithm that includes a yes or no question, we go from one that looks like that to one that looks like this. One of our steps is a diamond shape or a rhombus shape, and in that we put the yes or no question. And you have one side where if the answer to that question is yes, and one side where if the answer to that question is no. Different steps for that. For example, my same thing for getting dressed, I would say grab shirt. Is the shirt clean? Yes or no? If the answer is no, I put the shirt in the hamper. If the answer is yes, I put on the shirt. Do my socks have holes? Yes or no? If the answer is yes, throw the socks away. If the answer is no, put on socks. And you just keep going through this list. I could probably make this algorithm a little bit better to say, what's next after I put it in the hamper? Do I go back and grab another shirt? Maybe that's what I do. That's my next step. So anyway, these flowcharts help us make things visual. And that's what this is doing. Look at this algorithm. Look at the yes or no question. Do I have PE today? Yes. Make sure you pack your gym clothes. And if not, it just ends. All right. Now here's the fun part. This is going to be the challenging part. Figuring out your directions to get to the museum, that is easy. Let me come back to the map. Figuring out the directions to get from school to the museum, that's really easy. The hard part is writing an algorithm for, let's say I put obstacles. So right here, no left turn, right? And let me put a no right turn right there. Now we're going to make an algorithm that includes yes or no questions in it that needs to be able to work no matter where I put these obstacles on your map. Okay? And this is going to be the challenging part. This is what's going to take you a while to figure out, and you're going to have to go back and forth. You're going to have to erase all your steps and start over, because once you get an algorithm that works, I might come and I might move. I might move these somewhere else. Okay? So anyway, your algorithm needs to work no matter where I put these obstacles on your map. So you're going to include several yes or no questions. Your yes or no questions might be like, can I turn right? Well, this one would be the answer is no. So then, if no, turn left. If yes, turn right. Okay, something like that. Those might be your yes or no questions. You're going to have several of them, but then test it. Test it, move your obstacles somewhere else, test it again. Once you get your algorithm that works, so that it works no matter where I put those obstacles, then you have a good, we call it a universal algorithm. So that is lesson 1, your field trip navigation. Once you have an algorithm that works, take a picture of it, stick it in there, get it turned in.